So to pick up where we left off from Tuesday, if you'll remember right, when we got to the actual part of setting up the project, we created our Flask folder here. We set up our init.py. Remember that when you set up an init.py, it sets it up as an app or module. In our case, we just created the function of create app, which sets up some different characters here, or variables rather. And one of those it sets up as a database, and it's going to create this flaskr.sqlite database. This is just a flat file that'll get in here. It'll end up getting ran inside of your instance folder when you actually execute it. And you'll notice that instance folder by default is orange, which means what? Anybody remember? Kind of like your charts folder in the first couple assignments.
Is the orange it's in the get ignore?
Yes. Yep. So when it's orange, it means it's in get ignore, which means if we actually looked in here, we would see an instance folder in here. It's in here somewhere. But the idea is that anything in that instance folder will not get submitted to your Git repository, which is good. We don't necessarily want our SQLite database going out to the repository, right? So when people check out your app and use it for the first time, they should be setting up the database. There shouldn't be any real entries in the database to begin with. If you need entries in your database when you begin with, you will actually put them in the file that will create the database, so that once it creates the database, it would automatically enter those entries. And so we'll talk about that here in just a second. There's a couple different databases that you can use. Built in for Python is SQLite 3, works really well. You don't have to set up a separate database server. It's all built in, etc. When we talk about Django, you can also use SQLite in there, but that one, what's nice about it is it has some code built in that will allow you to adapt it very easily to other databases. So in other words, you write code and it doesn't matter what database is under the hood. So whether you choose to use SQLite, if you choose to use Postgre, and a couple other ones they support, it doesn't matter. You write it all in one way. When you write it in Flask, you have to write it specific to SQLite. You have to write it specific to whatever other database you might want to use. Right? The thing with that too is if you have a small application and you're just doing a little bit of reads and writes out of that database, it will perform okay off a flat file. But the moment you become bigger and have a bunch going on, you want a full-blown database server to run that off of. That way your queries happen much faster. All right. To connect to the database, in this case, it's a flat file, but we also have to connect and then create the file itself. So we're going to create a file called db.py. Copy this information into it. So inside here, we have our init, as we can see here. We want to create a new database file of db.py, add it to our repository, and copy that in. So looking at this, we're going to go ahead and import the SQLite 3 module for Python. That allows us to work with SQLite databases. We're also going to bring in Flask, the current app that we're working with. Notice that's a variable that we had set here. And then G, remember G is an object that we will be holding for the database itself. So we have two commands currently. We have get database and close database. In the get database, it says if DB is not in G, aka our current placeholder for the database stuff, it wants us to go ahead and use the SQL3 connect function in order to connect to the database itself. And we're just going to use the file that's set up. Notice in the current app.config/database, if we actually go back to our init, that database is referring to this variable, in which case we had set the instance path and then created Flask SQLite. So if that file does not exist, it will go ahead and connect to it there. All right. Or actually, in this case, it's just going to connect to it. It's got to get. We also have a closed database. And so in the database here, we're going to remove the DB from the file or the object. It's this object of G. And once we remove that, it no longer has a connection out to the database. Okay. Again, G is a special object that's unique for each request, and it's used to store data that might be accessed by multiple functions during that request. Okay. We need to create tables. So I know most of you haven't dealt with databases before, but the way databases work is you have an overall database file, and then you have a table, which is a set of information, right? And you may have, and you should have, multiple tables inside of your database file, depending on what you're looking to store. So in those tables, you will have columns and then you'll have actual rows of information in there. Columns being just like an Excel sheet. If you think of an Excel sheet, it's essentially like a database. All right. So you would have your columns across the top. Your rows are going to be your various entries of whatever information you're storing. In this case, Flask is going to be our blog application. Therefore, we're going to have a users table and we're going to have a post table, post being the blog or whatever we're submitting. All right, so we're going to create a file with those SQL commands in order to create those empty tables. So we will call this file schema.sql. All right. This is what preloads the database for you. So this is the same file that if you wanted to have preset entries into your database, maybe some preset users already set up when they deploy the application, you would put those inside this particular file. For now, we're just going to create our schema file. So inside here, and we'll do just a file, and we'll do a schema.sql. Add that and paste that in, okay? Go back to our deal here. So you'll notice you have the schema.sql, and then we need a Python function in order to actually run this so that it actually creates the database. So back in our db.py, we're now going to have two new functions rather. The first one will initialize the database and set it up if it doesn't already exist. And then two, this will be a command that we type on the command line. If you remember streamlit run, file name, whatever. This is creating a command called init-db, in which case it will initialize the database. So when you have them check out your project from GitHub, the first thing they have to do is run the init-db command in order to initialize the database. Then they can go ahead and run the file itself to run Flask. All right. That's what these two commands here do. The SQLite register converter is just converting date timestamps from like an ISO format to a standard timestamp. Okay. So we'll copy this. We'll go back to our DB file, and we're going to set these up down here at the bottom. Just like that. Okay. Now, one thing I want to show you inside PyCharm here, if we go back to this SQL, you'll notice you get this gray bar that says no data sources are configured in this SQL and provide assistance to code. We can configure a data source, click plus, and we are going to scroll down to SQLite. And once we have the SQLite here on this identifier, which is looking for this file, we can point over to the database. I'm not going to do that yet. I will show you what we'll end up doing with this. Again, this schema file is just for the purpose of us being able to create database. If you created a brand new database and log into that database, these are the commands you would use in order to connect and set up things in the database. So it's going to drop any table of user and post if it already existed. It will then create the table of user. Note that we have an ID, which is always a primary key. It's just an integer. So the first entry is 1. Think Excel going down the left-hand side, right? You have 1, 2, 3, 4, 5, 6, 7, whatever. That is your primary key integer. In your table of post, we have that same ID. And then we have two variables inside the user for table. We have user text. We have password as text. Note that on username, it has a unique field so that we only have the person with one username. It will not allow us to add a second entry with the same username. And not null means that we cannot have it blank. It cannot be set to nothing. We actually have to have something in there. So this by default will set the constraints so that the username has to be unique, it's required, and that we have a password that must be required. Right? In our post table, we have our author ID, which is just set to an integer. It turns out this will end up being a foreign key. We'll talk about that here in a minute. Right now, it's just an integer. We're going to have created, which will set a timestamp in the current timestamp. So when somebody posts a message on our page here or posts a blog, We are going to make sure that we take a timestamp of exactly when they do that. We'll also have a title field and a body field. Then we're setting up what's called a foreign key, and that will set the author ID of this table to point to the user ID of the user table, all right? The idea behind this, and you guys see this every day in applications you use on the website, is that this user one up here probably has more different fields out here, like email address, full name, last name, first name, that kind of stuff, right? It's a user profile. We could set that up here, but in our project, we want to set the foreign ID to that auth ID so that all we have to do is grab the auth ID here, then say, okay, I want the user that's associated with this ID, and I get all their profile information, right? So foreign keys are going to be references back to something. And the goal is that you actually utilize those in the proper way. All right. So that all seemed to work. The last thing we need to do is go into our DB file, and we need to actually create our init app, which will allow us to set up that init command that we created, as well as close and tear down any kind of database stuff. So let's go ahead and copy this into our DB. Good news is once you get one of these set up, it becomes a template, right? So with that one up, then if we look at these commands, again, that first one is going to tell Flask to call the function for cleaning up anything. And then 2, we have this add command so that we can do Flask init DB and it shows up. Last thing we want to do is go into our init and tell it when we create this app that we want to make sure that we import that database right off the bat. So you're going to see this style format in this tutorial a lot, which means I'm telling you where I'm at in the file. That's what this is doing. Then it's going to say all the existing code here is omitted. And we look at this file and we go to our init. We now have this app, which matches that format it showed. We're going to ignore all of this content until we get to return app. So we want to go down here at the very bottom before return app and have an option of from .import DB. Okay. What that's going to do is import from our DB file, just like we have done in our other projects. And it's going to go ahead and immediately call init app, which will call this function down here, which will then call the function to go ahead and do this stuff up here. Okay. So now we need to go ahead and create our database file. And to do that, we can go down here, copy this command line, but I'll show you what it does. If we bring up our terminal, make sure we're in the right prompt, and we need to go into FlaskR. So let's go into FlaskR. Actually, it'll pull it directly. So we will copy and paste this in here. And again, we are going to Flask app FlaskR. That's our project. And we are now running this initdb command. We created this command. It's not there by default. All right. Hit enter. And we see initialize database, and you'll notice over here under instance, you now have an arrow, and you now have the flask.sqlite. Okay. If we double click on that, PyCharm has the ability for us to directly connect to this as a SQL database, which means we can run our own SQL commands. We can already see what's in the database without having to write our web app to dump that kind of information out. It allows us to interact directly with the database itself. By default, you're probably not going to have this driver down here. So you'll click on download missing driver. And then you can test the connection. Make sure you get a check mark, hit apply and OK. And so now what this will do is it has a tab up here that's specific to your database. This is where you could run SQL commands if you chose to do so. So I could do something like select star from wherever. There's a bunch of other SQL commands we could do, and then you could run those. In our case, we want to use it in this right-hand side. Click on FlaskR, go to main, tables. We can see the 2 tables we created, user and post. SQL will automatically have these 2 in here, which are for its own internal database reference. But if we click on user, we can see that there's 3 columns, and we have our ID, username, and password. If we look at post, we have 5 columns of our ID, author ID, created, title, and body. Right? If we double click on those, we can then see what is currently in that table over here on the left. So I can now see my post table. Obviously, we don't have any entries in there yet. But this is a great way to see what's in the database before you try to write your software to pull this information out. The other cool part about this is you can spit this out as a CSV file, and therefore you can import this data back in if you wanted to. So if you wanted to create a CSV that helped fill in all this data, you could do that. All right. So that covers setting up the application itself, and that covers setting up the database file. Now we're going to move on to what a concept of blueprint is. All right. In order to see the pages of the code that you're looking at or write your URL, we use what's called a view function. All right. And that is where you set up your requests that come in, your incoming, outgoing, et cetera. So Flask will use patterns to match those incoming requests to URLs to the view that should handle it. And the view returns the data that Flask returns in its outgoing response. You will have a similar type process in Django. So the understanding these concepts is the same. Flask can also go the other direction and end up generating a URL to a view based on its name and arguments. We want to be able to use a blueprint, which is a way of grouping things together. So think about it in this particular case of a blog. We're going to group together the stuff that deals with the login page, aka login, logout, authentication. All of those pages will be grouped together. And then we'll have another blueprint that handles simply posts. And maybe we have another blueprint that handles, I don't know, user profiles or something over there, something that's not attached to those other systems. It's a way for you to organize your code so that you don't have one massive giant Python file where you have to skim through all that to find the right view for whatever else. It's an organization tool, kind of like files and folders, so to speak, right? So, and what's also nice is rather than registering the views and other code directly within an app, you can just register them to a blueprint. It makes them almost like an object within the project, okay? So in this particular one, we're going to have two blueprints, one for authentication, and we'll have one for the blog post functions. The code for each blueprint will go in a separate module, and since the blog needs to know about authentication, we'll write that authentication one first. So we're going to create this auth file. We'll copy this in. And we can close out some of this database stuff. We don't need to have that open here. Now, before I do that, let's go ahead and do a commit, right? We got too much going on. We should do a commit. And so in this case, we can say set up app and database. Let's go ahead and commit and push that. Perfect. And then back here, we'll go ahead and create our auth file. And so what these are doing is just importing our func tools from Flask. We're going to import the concept of our blueprint along with some other things that we'll use here in a minute. We'll see that we have this security section. This allows us to use functions such as check password hash, generate a password hash, etc. We are going to set up our blueprint. So BP equals blueprint. We're going to give it the name of auth, and we're going to set this URL to /auth. So anytime we're dealing with our auth stuff, when we go to our URL at the top, /auth is going to be this blueprint for it to go to. So we would have things like /auth/login, /auth/logout, /login/ whatever. You know what I mean? When we get to blogs, you'll have blog add, blog edit, blog post, you know, whatever you have inside of there. Okay. So that sounds good. We then need to create an init file, or we already have our init file rather, and we need to tell it about this blueprint thing that we just created. So again, down at the bottom, we want to bring in our from import auth. So if we look at our init file down here under this one that we did for the database, we would also import our auth blueprint as well. Okay. Right now, if you remember in our project, we look up here a little bit, the only page we have is this hello page, and notice it is at /hello. So if we go ahead and run this project that we currently have, go to our website, remember that nothing is at the root at the moment. If we go to /hello, we can see that something's there. If we go to /auth, we'll notice nothing's there yet. All right. What we want to do is set up one for registration where they can create an account on our website. And then we'll also go in and create other pieces of that. For now, we're going to deal with the registration piece. So let's copy this out and we'll cover each piece here. So in auth, we're now going to have our function. You'll notice this is set up just like we did back here in our init when we did our hello. We always set up an app route, tell it the route that we want to use, and then we have a function that marries to that as to what we're actually going to do in that. So in this register one, we're doing /register. Remember yesterday, or Tuesday rather, we talked about get and post. Our register page should have a get and a post, right? It's first going to do a get to pull the page itself down. The user is going to fill out the registration information and then post that information back to us. Okay. So we have our function here. Notice that the first thing we check is to see if it is a post, because then we want to process the information. It's then going to take whatever the form is that they submitted. We're going to take the username they submitted, the password they submitted. We'll go grab the database and then set our error to none. We'll check to see if there's not a username. In other words, they didn't provide us a username, then we give an error of usernames required. Remember, in Python, we're going to do these checks in a row. So the next one it's going to check is do you have a password? And if we have an error, password is required. So if they didn't submit those two in the form, we're going to throw back an error. As long as the error is none, then we're going to go ahead and insert those into our database. This is SQL language for putting this in the database. You would have something like insert into the table name. The variables that you want to insert in, notice that those are in parentheses, and those are the fields that you're going to put those in. That makes sense? Username and password is correlating back over here to our username and password inside of our database. Okay? Values, and then we use what are called question marks. These are kind of placeholders, all right? So for every one of these that you're going to store, notice that in this one, we only have 2. The ID is auto-generated for us. We have to have the username and password. We also have to have 2 question marks out here. I'm stressing this because that's where most people screw up if they haven't played with SQL before. If you have these set and you had them set to not null, you must provide them when you do an entry in the database. If you don't provide them, it's going to get kicked out with an error. All right. In this case, you'll do this. And then inside here, we're running the variables that we want to submit. Notice that we insert the username they gave us from the form, but we're then going to take their password and immediately run the function called generate password hash. All right. In other words, what are we not doing here in our database? And you cyber guys should pick up on that.
So we're not storing the actual password, we're storing the hash.
You got it. We're not storing the raw password that they submitted to us. We are generating a hash of that said password, okay? That functionality comes from that WorksCrew security package, all right? We are importing 2 functions from them. We're doing a check password hash. Obviously, we'll do that at the point of login, right? Or we're going to generate the password hash at the point where they actually are registering their account. So then once we do this execution, we must run a DB commit. This is another one people screw up, right? You insert it in the database, it's not there till you do a commit. Kind of like GitLab or GitHub, right? Your stuff isn't there until you actually commit it. Right now, it's just working changes until you hit commit. All right. If we get any kind of error in here, in the case that they tried to do this, we are going to use our try and accept to give out the user that it's already errored. In other words, we would get this integrity error back out of SQL if that username has already been registered. And remember, the reason we would get that is because over here in our schema, we said that this must be unique. All right. So if they try to register with the same username twice, it would then tell our system that that's not not unique, and therefore the error it throws is an integrity error. Okay. If that works and we are able to commit this to the database, then we hit this else statement, which then says redirect the user to the URL for our auth.login page. Obviously, we don't have that yet. We have to create that yet. But the idea is if they have a successful registration, we will automatically send them on to our login page. If there is any kind of error up here, like they forgot to submit a username or password on the website itself, we will use our flash function to flash that error on the screen. All right. Remember, that's a built-in function of Flask. Outside of that, when they are requesting our page, notice all of that happens in a post. If they are just asking for the page, we are going to use our render template function and then pass them the HTML template for our registration page. Okay. I know that's a lot of information. Yeah.
So that flash error, does it work similarly to print just from a Python standpoint?
Yes. Yes. Under the hood, it would be like print, but instead of going to the console, it's going to flash that error on the screen to the user in the web application itself.
And that's a Flask function then?
Yes.
Or yeah, Flask.
Yep. Okay. So this is going to explain all that stuff I just explained there. We now need to create our login view so that we can have them redirect to this after they log in or register. So we'll take this same information. Again, this is going inside of our auth blueprint. So let's go to our auth one. Down here under registration, we have our login view. Okay. Now, login will also have a get and post because we're going to request the page. They're going to log in with their username and password, hit submit, and therefore it becomes a post as well. So similar to what we did in register, we'll have our request method a post if it is actually submitting information to us. Here we are taking in their username and password. The difference is this time when we go after the database, we want to pull the user from the database. In other words, select star from user where the username equals the username that they submitted. All right. You'll also notice on this database command that we are only fetching one result, and there should only be one result, right? Usernames are unique. Therefore, there should not be ever where the username is repeated in the database. By our own design, there's no way of that happening. Select star means that we're selecting all the information for that user from that database, right? Therefore, we'll get back the username and password. If that user is set to none, then they didn't give us a correct username. If that not, the check password hash, meaning we'll take the hash from the user out of the database, we'll take the password they entered, and then we're going to run it through this function of check password hash. Nope, this is done server side. So they send their clear text password to us because it's HTTP at this point. We're going to send it to the server. The server is going to check the hash that's in the database with whatever they typed and see if those two hashes match. If they do, it continues on. If it doesn't, it throws this error of incorrect password. As long as we got no errors, then we will go ahead and clear our session. We're going to set a new session cookie for us in which the user ID of that session is set to the user ID from the database. And we're going to redirect them to our index page or our main page coming for our project. Once again, if there's an error, we're going to flash it on the screen. If it is a get, AKA the first time they go to this login page, then they want to pull the login.html file. All right. Down here, we're also going to set up whether or not that user is already logged in. So if they come back to this registry or login page, we want to know if they're already logged in, go ahead and pull that information back and redirect them to the index page. We should not have them log in twice. So what this little setup is going to do is say, if the user's already logged in, AKA they have a session cookie set, If that user ID matches the user that's trying to go through there, then we're going to go ahead and fetch that information back out of the database. Right? It just means that if that user is logged in, we're going to pull that information out based off their session cookie. Okay. We need a logout page. So let's grab this for our logout page. And on a logout page, it's very simple. We simply clear the session cookie and redirect them back to the home page. Make sense? Pretty simple. We don't need to go in the database and create anything. We're just going to clear their cookie and send them back home, at which point the system will recognize they're no longer logged in. Okay. Now, we also want to make sure that when we have pages, for example, the post page and that kind of stuff, that they must be logged in order to get a post page. Make sense? We'll see the index page with all the prior posts of people, but if we want them to add a page or add a post, they must be logged in order to see that. So to do that, we have to write a function that checks to see whether or not they're logged in. And that function here goes through and says, okay, for that user, if you have one, then go ahead and return all their values back. If that user is not logged in or it doesn't exist, redirect them to the login page. Okay. So all those URL4s, you'll notice that when we did this URL4, this is looking for auth login, which is going back to this route that we created right here. Auth login function, right? This one up here, it says redirect for auth login. It's going to send them down to this function. If we have this one, which will render a template, now we're giving them an actual HTML page to go get. So we'll have to set up our HTML stuff here shortly. Anybody have any questions on how those endpoints work, the URLs, how they're generated?
So each one of those snippets of code you put in, we're just adding to the auth file, right?
Yes. So in this case, this is all under the auth blueprint. Everything we did here deals with authentication. Therefore, we wanted to stay in the auth file.
Okay.
Yep. Now later, when we deal with the posts, we'll create a post blueprint and keep everything associated with the posts in there. It's a nice, clean way of doing it. The other beauty of doing this is if you do this auth right, you can copy and paste this to 3 or 4 projects and you get that functionality. Does that make sense? You can reuse your code in multiple projects. If you built an elaborate user system that has to log in, one-time authenticate, all that stuff, and put it in one blueprint, you can now take that blueprint and insert it into multiple projects, as long as everything jives in that regard. Now in Django, we would call those Django modules. So when you guys are looking to add extra functionality in your Django, people wrote extra modules for you. All they did is write them in a way that it's quote unquote containerized so you can import them. Same way within Flask, you can use Flask modules to do the same thing. All right. So that worked there, and we created all of our views. Now you'll notice that they pointed to templates, and we need to create templates in order for that to work. So anytime we call this render template, it's trying to render HTML, and we need to create a folder called templates to store all of our templates in. Remember, for templates, we're going to use Jinja. And the idea behind that is that we don't have to write a bunch of HTML code. We don't have to escape that code. That's all part of a Jinja template. It also allows us to work as if we are basically using Python right in the HTML code. So anything that's used between double curly braces will output some kind of final or output that outcome of Python into your final document. Right? So if I say if 1 = 1, print OK, and 1 = 1 does equal OK, therefore in the final document of HTML, it just says OK. So that's how it works. If you're doing flow control stuff inside of a Jinja template, you need to use the curly brace and a percentage. This would be something like if something, then do this, or for loops doing this, you have to use this denotion, right? Again, the good news is you're going to get to copy and paste a lot of this. The big deal with our templates is the idea of inheritance, which means we set up our base layout. Remember, I talked about this on Tuesday, where we want to always have our top bar and our bottom bar and maybe our sidebar. We have to figure out what that layout is. And that way, if we change any of that, we don't have to go change every single file. We just change the file everything inherits from. So we set up what's called a base HTML file. This will have everything like our CSS and all that kind of stuff in there. And then our inner ones work inside here. So if you look at this base template, we create a section called content. We will dump content into that section dynamically through our other templates. Copy this out. We're going to go to our Flask project up here, create a new folder called templates. And then inside that, we're going to create a base HTML file. And you'll notice in PyCharm, it automatically gives you a default HTML template. We're going to remove that and paste this in. So with a basic HTML file, it's going to have our block title. This is the whatever we call it up here. So if we have a block title template, it will fill it in this placeholder. And that will fill in basically here, right? We have Flaskr that shows up here. This title section, if you've ever been on a website like here, the title for this page was templates Flask documentation, right? We're building one that says whatever we want it to dash Flaskr. So we pull in this title variable and dump it in there. We're also going to pull in a style sheet or a CSS style sheet for our style.css. Note that it's pulling from a file name and it's static. So this will be a static folder we'll have to create over here in a little bit. We use an H1 title called Flaskr. We're going to see if the user's logged in, right? That's where g.user comes from. If the user's logged in, we'll say whatever their username is on the upper left, and then we give them the option to log out, right? If there is no user, we use an else, and that else will give them two buttons, or in this case, two options that says either to register or to log in, right? We create this placeholder called content. Inside that placeholder, we have a placeholder for header information. We can also get our messages, and this is that message, error message that we talked about that will end up flashing it on the screen. And then we can end that, and then we have another holder for our actual content itself. So we'll talk about these in a second. So on our register page, we're going to create this register template. Let's copy this here. Create a new HTML called register. Take out what's in there and paste this in. So what this does is it pulls all this information from base. You'll notice in this register, we're extending our base file. It's going to look for the block header section, which if we look in here is right here, right? So this entire line and everything in between it will get replaced with this block here. So when we're done, that HTML file will copy and paste this, dump it into this part right here. That's the point of inheritance. Then on the block content, we have a simple little form that asks for their username. It has the label there, has an input. This is standard HTML stuff. And then you'll have a label of password and an input field for password. Notice that we give it the ID of username and password so that we can pull that out later. Where we're pulling that out, if we go back and look at our auth and see how we have request.form and then it asks for the variable that we're pulling, that is what we're setting up right here on the register. Username, password correlates back to our file here of form.username, form.password. All right. We also have a button here that's called submit, and that value is register. When we set up our auth and we go to our register page, if they submitted that in a post, then we can go ahead and get this information out of there. End our form and dump it in. So it's like taking this section here and we're going to copy and paste that right here. That's what the whole point of the inheritance is. So that's cool. That'll set up a nice simple page. On the login page, let's take that example template here. There again, we're going to extend our base template, only this title is now going to be called login. And for that page, we'll also have a form page, but we're also going to have them just log in with username and password. So notice that the only thing that changes is the button goes from register to login. If we look between these two pages, register and login, the only thing that realistically changes is the title and the button that we have them log in with. Now, you guys have all used registration and login pages. They should look a little more spicier than that. We'll fix that later on. Right now, we're at a very basic level of what we're trying to do. Note, when you're working with two files like this inside PyCharm, if you're not familiar with it, right click on this one up here, go to split right, or you can do split and move right. I suggest you use the second one. That will end up splitting this screen and moving that file to this side so that you can do a nice side-by-side comparison. If there was a bunch of files here, you could scroll up and down and compare the lines between it. It's really slick for you to be able to see. So like here, we can clearly see the differences between the two. If you wanted, you could actually do a diff over those. It's a little more complicated, but you could actually do that to compare. All right. Scroll down here. And at this point, we now have all of our authentication stuff set up. We have some templates. We have our views, we have our pages built out, so we can actually go ahead and register a user at this point. Let's go ahead and run our project. Note that we got to stop the existing one that's running, rerun it. We'll go out to our website. Notice again, nothing's up because we don't have anything for our homepage yet. Didn't set anything. We can check and see that hello is still there. It is. If we go to auth, notice nothing's there. Why? Because there is no route called auth. There's only a route called auth login. We see that we can't get that page. If we go back here to PyCharm, what do we see down here?
Error code 500.
Yeah, we got a 500, which means we have an internal server error. And if we come up here and look at this error that's up above, the reason we're getting this is on the auth login get. So we need to come back up here to our auth project. Let's go look at our login page like this. And when we look at this last little part that says auth login.html, you'll notice that we cannot find that template. We have the template over here. So what did we miss, or what were we supposed to set up? Okay. Notice that login's not there. They want us to test out register. So let's go test out register. You'll notice we also have a registration issue of the same thing, cannot find the template. So here's what I'm thinking. I'm thinking I put my templates in the wrong place because I have a very bad history of doing that and all of that. No, I actually did it right. Templates. Base.html. Oh, I know what I did. Does anybody see what I did wrong? Like I said, I screw up this base thing or the template thing all the time. What's the difference between where it told me to put this file here and what it told me to put this file here?
Register.
Yeah, we forgot the auth subfolder inside templates. And the reason that's important is because it deals only with the auth blueprint, right? So because I have them in the same base directory here, it's looking for that auth folder and it can't find it. As a matter of fact, if I took this /auth out of there and hit save and restarted this, come back here and just go to /login, you'll notice that page doesn't exist. But if I go to auth, auth login, you'll notice it actually works this time. However, the reason it's working is because I told it to just look in this base directory of login. We want that to be in a subfolder called auth. So I'm actually glad I screwed that up because that is one of the big mistakes everybody does. So you want to stick these inside there. We'll refactor these like that, there, and then back here, we want to put back in our auth slash. Again, the reason that you want to keep those separated like that is if you want to keep this project modular, you want to be able to just copy off the auth folder to your other project. All right. So that works. We can go ahead and stop this. Let's start this. Let's come back here, and instead of login, let's go to our register. Now notice this is not a fancy website, right? It's not intended to be. We don't have any fancy styling. Remember, we have no CSS at this point. We are just generating raw HTML. Speaking of that raw HTML, if we look at this over here, you'll notice we have our head of register dash Flask. If you come up here, you can see that title up here in our tab. We have a style sheet we're linking to, which is style.css. If we actually come back to our project, what are we finding out about that style CSS? Doesn't exist, right? We haven't created it. That's why it looks like garbage HTML at this point. It's just not been styled. If we come over here to the body, notice it's really helpful to use inspect here because you can see what part correlates with what. In the body, we have our H1 of Flaskar. We have a UL. And in this UL, we have a list, right? UL means what? Does anybody remember from HTML?
Unordered list.
What's that?
Is it an unordered list?
Unordered list, yep. So in that case, our first one is set up as register. Note that the URL here was automatically generated, right? Auth register. And now you say it's automatically generated because if we go back, look at our template for register, here, right? We got those up there. Notice in our register page, that doesn't exist over here. It's because we have that in our base file. In our base file, we created this unordered list of being able to register or log in. So in this case, because we're not currently logged in, this if statement was not true. That's why we don't have a logout page. We hit the else statement, which then means that we get these two unordered lists. Notice that the href we said was get the URL for auth register. At the time this project compiled and actually started a web server, it replaced everything in here with the actual URL for register. How did it find it? Well, it went to the auth file, went to the registration one here, came down and grabbed this login. That's how it knew where to go. Everybody kind of see how this ties together?
Say that again. Say that again.
Yep. So over here, we'll notice if we look at it, it's auth register. If we look in our code, it told us to go get the URL for auth register. So what it did was go into our auth blueprint, go look for the registration one or the register one that we asked for, and it pulled this title here, knowing that we're in the auth blueprint. So it generated that URL on the fly based off where it found it out of there. It's important because otherwise you have to hard code everything. You don't want to hard code everything. Otherwise, you're going to have to be changing templates all the time. All right. We've got that. If we get down here to the section on the actual content, notice this down here, we had a real simple form, and that form gave us a label of username and then the input for the username. The input or the label for password, and then the password, and then we have the register button. So let's type something in there. For example, user password and hit register. You'll notice that at the moment it registered, we didn't get an error there, right? Which means it actually was able to put things in the database because remember we had errors set up for that, and it redirected us to the auth login page. Notice that the button for that changed. Same look and feel on this page because it's the same HTML essentially. The only thing that changed was the login here. Now, if we go back to our program, we'll notice that when we did a post of register, everything worked just fine. Notice what that last part there is on 302. Does anybody remember what 302 means? Power of Google back there says?
It
Indicates a temporary redirect. We have a request.
Yep, so if we look at our register, in the event that everything went correctly, we have a redirect to the login page. That's why you get a 302 here, right? We told it if everything worked, go ahead and redirect us back to the login page. So the reason I'm spending so much time on this, you guys get lots of error logs down here. Use them to your advantage so you know what's going on. Because later on when you're troubleshooting, these numbers really matter in here. Remember 200, thumbs up, everything worked. 404, not found. But it also didn't crash the system. Does anybody remember what the one we saw crash the system is? The quote unquote internal server error?
Was that the 500?
Yeah, 500. Yep. So kind of mental note, jot down those HTML error codes or HTTP error codes, because that will help you troubleshoot what's going on.
So the easiest way to find these, when we do get them, is just to through like Google HTTP error code, whatever the number is.
Yeah, absolutely. Yep.
Okay.
Yeah, and I encourage you to use that. Like, you don't have to memorize them, but as long as you know how to go look it up, if you don't remember it, that's all that matters. The cool part is, as we talked about things like ChatGPT and some other stuff, copy and paste this baby right into it, and it will give you some direction as to what's going on. It will look up the 302. Oh, hey, by the way, you got redirected. It looks like everything went well.
And if you have your code in ChatGPT, you can cross-reference it.
It could cross-reference it. Yep. So here, if we actually copied this in and said, tell this as a story, it would literally spell it out like it's a story. A user came to the auth register website. We gave a 200. The page loaded successfully. However, we can't find the style.css file for that. So we gave a 404. We also tried to look for your dev tool stuff. It looks like maybe they right-clicked and used inspect, which we did, right? Then we went ahead and had somebody give us a registration. Notice they posted that information to us. We then, it was successful, and we redirected them over to the login page.
It's funny that it tells you they use dev tools.
Yeah. And that's a request there again, because Google is requesting to say, hey, is there a dev tools JSON that formats and highlights? What that is there a config file that tells me how to do this layout over here?
Could you block a website from detecting that?
I mean, you could just not have the file available. You can always right click because you're just reading HTML raw. A lot of times where that gets used the most is if you build in a debug file. So we could build in that JSON to colorize things so that we could find things while we're deving and then remove that file for production kind of thing. All right, this worked. If we try to log in with somebody that doesn't exist, notice we get our incorrect username that popped up here. That error comes in because when we generated that page, notice up here, we posted our login and we sent back the same thing. We didn't get anything back out of it. If we go to login, you'll notice we got incorrect username in here. That's because when it tried to fetch it from the database, we got no user coming back. Therefore, we're going to pass the error. If the error is none, clear session, blah, 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 we did get an error. Therefore, we're going to send Flash over here. When we look at our base HTML, notice that we get Flash messages, and then we're going to say for every one of those messages, print out the message. So there's a chance you may have gotten 2 errors in the process of updating, in which case it does a simple for loop and prints out all of those error messages in that same spot. We could actually build this as a box that says errors here, and any errors, if it pops up, would show up in that if we wanted to. You wouldn't normally do that, but it's always going to show errors right here on the page. It will not put them at the top. It won't put them at the bottom. It's only because in our template, we said, this is where I want my errors to show up. If I move this error little section from the header to, well, it has to say there. Over here, we could see that those errors would pop in on that space. It's always before the content. If I took my content and put that above I could do this correctly here, like that, where our content's now above the messages, and we save this base page, and I refresh this page to just auth login with a get, Notice the error message should not be at the top. I gotta stop and redo it. I changed the URL. It will cache it. Okay. Go back to our auth login. Notice the error message is now at the bottom of that. All right. So however you have your template up for where that's located, that will dictate that side of it. Okay. Save that, stop that, run that. Okay. Couple other things. When it did this request in here, on the registration page, if we just type in a password, notice that we get an error that that field must be required. All right. If we do a username and no password, we have a field that is required there. If we type in, what did I call that other one? User?
Yeah.
If I do user and do a new password, try to register, it tried to put that in the database, and because that was not unique, it already knows there was that user in the database. We can also come out here to our database. If we double click this SQL instance here, right? We got this here. I could do one of those other commands manually. For example, select user where user is this. So let's do that just so you guys can see what that looks like for troubleshooting. And instead of that, we are going to say our user is user. And then we will hit the play button and it's going to run that command and pull that information back. In our database, it went to the user table. That's what this user part's for. It says, grab me everything. In this case, all the columns where the username matches whatever this variable is, in this case, the word user. You'll notice in the database, it's storing my username as user, my password as a script hash. Okay, much harder to decode. So if you were somehow able to dump the database, you would have to then decrypt this particular password. Now, the bad part is if I could intercept this traffic directly, because this is HTTP and not HTTPS, I can see when they submit their information out to our web server, it's in clear text, whatever they typed in password. All right. To see that, if you want to see how that works, let's come over here and do a JSON and do a test. You'll notice when I did this registration up here, and if we scroll down over here on the right, we would actually see that in raw text over here, payload, JSON, and test. All right, that's another reason you want to do things in HTTPS, because anything you submit would be doing that. Now, there's a couple of tools out there where you could, in JavaScript on the fly, when I type stuff in here, it runs JavaScript in the background to actually encrypt that as I type, and therefore it submits a hash going through there. Right? Before it ever leaves the computer from this machine, it's going to be encoded going up.
Receiving in would need to know.
Yes, so because you know what key or value you did in the JavaScript, it would then be able to decode it on the far side, and then you could re-encode it in a different hash to put in the database. That makes sense? Cool. All right. Where are we at here? 2:30? Let's see here. So we have our registration. We know our login works. And if we come back here, let's close this. The other thing I was going to show you is if you come over here and double click on the username, you can then see all the entries that are in the database, right? You could either do it this way where you do a select from whatever, or you can just go see raw what the database looks like. So when you guys are trying to troubleshoot, this is where you would go to troubleshoot what's already in your database. Cool. We have this thing like select star. If we say select password from user where it's that way, and then hit play, notice it only brings me back the password. It didn't grab the ID. It didn't grab the username. It just grabs the password. So most of the time you want all the information back from that row, but there may be times where you don't want, say for whatever reason, you have 14 columns of information, right? Well, remember, every time you do a request to this, the system slows down because it has to go pull all that information, package it, send it out to your web application. The web application has to depackage it, use whatever it's going to use, and then send it out. If it's sending a bunch of extra data that you're never going to use in that request, you're just wasting bits and bytes. Does that kind of make sense? So you kind of want to clean that up as your project's going along, especially if it's pulling large amounts of data. Okay. One last test is if we come back out here to our login and actually use the correct login. So user and login, you'll see that we got a 500 error here, right? Internal server error. And if we go back to our project, which is running down below here. I got too many windows open now. That one. You'll notice that we got the 500 because there is no such thing as an endpoint of index, right? We never created our homepage yet. So because we got logged in and everything's working correctly, it just has no idea where to send us after we did that. All right. So to do our index, we need to go ahead and create our other static files, like our CSS file and some other pieces there. This will be the last one we do here today, is set up our static files. Static files are things that are fixed. We're not actually trying to plug in variables and things like that, like we're doing HTML, where we're building it on the fly. So we need to create a static directory, and then we're going to serve this up as regular files. If you guys have ever hosted your own little HTML website, you did this obviously in 250, right? In the web server class, you built out a bunch of HTML, some CSS, put it on a web server, it hosted out to the website, and you got a website. The only difference is instead of having an HTML file up here, you have one, but it's a template. We're generating that text on the fly of what goes in that HTML versus it being a static page, where it always is the same thing. So to do that, what we will then do is create this URL for static CSS. We need to create our own style sheet coming in here. And so if we copy this style sheet and we create our static folder here, and we have a new style sheet, which is obviously still baked into PyCharm. You could call this one your style.css, add it. And if you paste this in, it will help give you information. So for example, it already has it colorized where this is blue and these are whites and this one's red when we have issues, that kind of thing. This is just a style sheet that you guys could use from default. If you want to change those colors, what's nice in PyCharm is you just come in here and tweak this color. Maybe I don't want that red, I want this red. And it automatically updates within your style sheet. So you don't have to guess the hex code for whatever else you were wanting to do.
I would much rather prefer this.
Right. So much easier when you want to do that. When you want to flash things, we talked about that. It tells you what border or something we would want to flash that around. So to make sure this style sheet comes in, we have this submitted here. This looks good. You can now find a login page, and if we restart our web server, go out here, we should see our /auth/register. We have a much prettier looking website right off the bat just by doing a little CSS with it. Okay. Notice that we are currently logged in because it has that session cookie from what we did earlier. So we can log out. Again, we don't have a logout page. We're going to have to create that here in a little bit. If we do a login page, we can see this here. Notice that because we're not logged in, we have the option of registering or logging in up above here. Okay. Obviously, we will want to tweak this and make this even prettier going down the road, but basic CSS, it looks pretty good. Now, the cool part is if you're not great at CSS, you take this, you send it to ChatGPT and say, I want this to look like this, or change this to look something like this, or give this a theme of spooky Halloween. I don't know. And it's going to tweak the CSS and then tell you what you need to tweak your HTML in order to make that work. So again, this class is not a web development class. All right. I want it to look decent, but I also don't expect you to have a super polished CSS file and everything else. Do that towards the end of your project. Like get the cool features, which you'll need some cool features that's baked into your final project. But don't spend so much time making everything look pretty. Make sure it's actually functional. That's what I care about. Because on the functionality side, AKA all the routes and all the views and everything you built on the backside, that's what really matters in this class. All right, we're going to stop there. We have the blog blueprint next. So you have the ability to log in, register, do all that. We're going to create our blogs. And then after we get through our blogs, we're going to go ahead and make that to where we can set that up to be installable with other people. We can write some test packages to make sure everything's working correctly. We'll do this for production and then what you can do to keep developing and working on this project. All right. So we're almost done towards the end of this tutorial. We just got to get the blog portion of this up and going, and then we'll be good to go. Safety's sake, let's go back out here on my commit. I probably should have done this a little sooner, but at the same time, we can say created auth blueprint and views. Commit, push. And today's work saved. All right. Anybody have any questions on anything so far? Again, I know that's fast, but the idea is that you should be able to go back, watch the video, pause it, stop it, do everything you need to do. But you have a working project at the end there.
So Jason, is there just a little bit ago, we couldn't find our index. Why did that give us a 500 error and not a 404?
Because in this case, we are trying to route to a specific error. And if we come up here to that page where that index is, let's see here, auth login. Here, it's looking for the URL of index. And because it's not looking for an HTML file, it's actually looking for the index route. Or in this case, the index view is what they're calling it. So we have a register view, we have a login, logged in, log out, but there's no index one. And that's why it fails. In other words, it's a server-side error. It's a Flask error that you're trying to route me to something that doesn't exist.
Okay, so I'm just trying to wrap my head around that. It sounds like it's able to find it. It just doesn't exist.
No. So a 404 is referring to a file typically. So like, for example, if we come up here, our CSS file didn't exist beforehand. It does now, right? But like here, if you try to go to the main page of slash, our 127.0.0.1 on a slash, when we go here, we get a 404 because that page doesn't exist, right? In this case, the route itself, well, it doesn't come up because we don't have the server running either. But if I come back here, this not found is us requesting that particular route, but it doesn't exist. The difference is here when we told it to the server is supposed to generate this URL for index, it can't even generate the URL. That's where you're getting your error. Does that make sense?
It does. It looks like I need to go back and reread some of that stuff. It's been a while since I've done any web stuff.
Yeah. In other words, there was no index URL, but because this is running this code, in other words, think of this function. If we say, give me the URL for index, but the variable index doesn't exist, then Python's going to crash. If Python crashes, that's a 500 server error. If it's just that the page doesn't exist and it doesn't know how to load it here, it generates a 404. Okay. And that is actually defined in our init here. And if we wanted that 404 to be something else, we would tweak that in our config file. That was part of what we did on Tuesday, if we wanted. So eventually we wouldn't want this /hello in there, right? That was just getting started kind of stuff. In production, we wouldn't want that to be available. All right. Musa, Sam, you guys got any questions? Nope, put him to sleep. All right, I'm going to stop the recording.